Requirements of level crossing gate. Regarding requirements of level crossing gates like interlocking of gates with signals, normal position of gate, telephonic communication from the gate lodge, warning bells or hooters operated by approaching train, type of lifting barrier, and approach locking are given below in tabular form. Requirements of level crossing gate is as per revised Annexure 10 of Para 14.1.7 of the Signal Engineering Manual Part 2, 2001 edition, addendum and corrigendum of slip number 6 is given below. Classification of gates is based on train vehicle units. For train vehicle units greater than 50,000, it is called Special Class Gate. For train vehicle units greater than 30,000 and less than 50,000, it is called A-Class Gate. For train vehicle units greater than 25,000 and less than 30,000, it is called B1 Class Gate. For train vehicle units greater than 20,000 and less than 25,000, it is called B2 Class Gate, and for train vehicle units greater than 3,000, Category 1, and train vehicle units greater than 2,500, Category 2, is called C-Class Gate, that is manned. A. Regarding interlocking of gates with signals situated within station limits. For special class, A class, B1 class and B2 class, gates should be interlocked with station signals. For C class, that is manned, gates should be interlocked with station signals in suburban section and in automatic block signaling. In non-suburban section, it should be interlocked with station signals if the level crossing gate is operated from the nearest cabin, or if it has to be interlocked for any other reason irrespective of the place of operation. For other stipulations, to minimize the mean waiting time for road users, the arrangement of interlocking should be such that the last operation before taking off of signal should be the closing of the gate, and the first operation after the train has cleared the level crossing and the signal is put back to on position should be opening of the gate by gateman. B. Regarding interlocking of gates with signals situated outside station limits. For special class, A class, B1 class and B2 class, gates should be interlocked with gate signals. For C class, that is manned, gates should be interlocked with gate signals in automatic block signaling sections. For other stipulations, in case of level crossing protected by signal, where the sighting of the signal by an engine driver is inadequate and the gate signal is pre-warned through other means, that is, distant signal or independent warner signal or repeater signal, etc., a warning board should be placed at not less than the emergency braking distance in the rear of the gate stop signal. The board should be vertical 2000 mm by 450 mm with alternate black and yellow strips 125 mm with painted on it at an angle of 45 degrees. 3. The top of the board should be 4 meters above rail level. The board need not be lit at night but should as far as possible be provided with Scotch light or other effective light, reflectors or retro-reflective tape. Where level crossing is situated outside station limits but in close proximity thereof, the clear distance between the level crossing and an outer signal should not be less than the full train length. Note: all manned level crossing gates, both within and outside station limits, falling on suburban section and automatic block signaling section, shall be interlocked irrespective of the classification or train vehicle units of the gates. Regarding normal position of gate, for special class, A class, B1 class and B2 class, normal position of gate shall be normally kept open to road traffic. For C class, that is manned, if interlocked, shall be normally kept open to road traffic. Regarding telephonic communication from the gate lodge situated within or outside station limits, for special class, A class, B1 class, B2 class and C class, that is manned, telephone communication to be provided with Assistant Station Master's office with all manned level crossing gates. For other stipulations, in block sections having number of level crossing gates, the connection should be uniformly distributed between the block stations. Regarding warning bells or hooters operated by approaching train situated within or outside station limits. For special class, A class, B1 class and B2 class, warning bells or hooters operated by approaching train should be provided. For C class, that is manned, warning bells or hooters operated by approaching train should be provided, where level crossing is outside the station limits in all suburban sections and non-suburban sections provided with automatic block signaling territories. For other stipulations, provision of warning bells operated by approaching trains should be confined to interlocked level crossing gates only. Hooters shall be provided wherever power supply is available. Regarding type of lifting barriers situated within or outside station limits, for special class, A class, B1 class and B2 class, electrically operated lifting barrier to be provided. For C class, that is manned, electrically operated lifting barrier to be provided in suburban section. For other stipulations, in non-suburban section, electrically operated lifting barrier to be provided where power supply is reliable. Regarding approach locking situated within or outside station limits, for special class, A class, B1 class and B2 class, approach locking to be provided in suburban section, and dead approach locking with timing of 30 seconds in other sections. For C class, that is manned, approach locking to be provided in suburban section and dead approach locking with timing of 30 seconds in other sections where electrically operated lifting barriers are provided. Dead approach locking with timing of 30 seconds in other sections where electrically operated lifting barriers are provided. Location of level crossing gate. Classification of gate as per their location or operator of the department. The gate, depending upon their location within the station limits, that is traffic gate, or outside the station limits, that is engineering gate, is called traffic gate, which is also known as station gate. Gate situated within the station limits may be protected by station running signal and manned by traffic department. These gates may be non-interlocked or interlocked with signals. Engineering gate, which is also known as section gate. Gates other than traffic gates situated outside the station limits, that is block section, may be protected by gate signal and gate manned by engineering department. Protection to interlocked engineering gate. The interlocked engineering gate is protected by signals which are provided with a G marker and called gate home signal. The gate home signal shall be placed at a distance of block overlap from nearest end of check rail of gate. A loco pilot can pass a gate home signal at on by following the stipulated rules. A goods warning board shall be provided if speed of goods train is more than 72 km per hour. Where sectional speed is more, a separate independent warner signal shall be provided at a distance of 1200 meters in rear of gate home signal. Protection to traffic gate. This gate is protected by the fixed signals of station. Generally, when the gate is located within the station section and in the route or overlap of the signals, then the gate shall be interlocked with these signals. Whenever the gate is located in the block overlap, then the first stop signal is shifted at a distance of block overlap from the gate. If the shifting is unavoidable, then the gate is to be ensured in closed and locked condition before granting line clear and remains closed until such time train is received. 2-aspect signal on single and double line. Level crossing gate between outer and advanced starter signal at Class B station on single line. In this case, outer signal is shifted to block overlap distance, that is 400 meters in rear of gate. Where sectional speed is more than 50 km per hour, a warner signal can be placed below outer. Routing home and advanced starter are to be interlocked with level crossing gate. Interlocking of outer is not required as outer is released by home. Level crossing gate between advanced starter and home signal. Signal to be interlocked are up and down routing home, up starters and up advanced starter. Up routing home signal is also interlocked as gate is located in the overlap of this signal. Interlocking of outer and warner is not required as outer is released by home. Level crossing gate between home and starter signal. Such location of the gate is rare. Signals to be interlocked are up and down routing home, up starters and up advanced starter. Up routing home signal is also interlocked as gate is located in the overlap of this signal. If loop line point is provided with sand hump, then up routing home shall not be interlocked with gate when overlap is set to sand hump. Level crossing gate on birding track. Such location of the gate is rare. All the reception and dispatch signals shall be interlocked with gate except advanced starters. Level crossing gate between home and distant signal. Level crossing gate in rear of the home signal. In this case, existing home signal and up advanced starter is shifted and placed at a distance of block overlap in rear of the level crossing gate. An additional home signal is provided at a distance of block overlap in rear of the level crossing gate, and existing routine home signal is shifted near the first facing point or to the fouling mark in case of trailing point. Down home, down routing home and up advanced starter are to be interlocked with level crossing gate. Level crossing gate between home and distant signal. In this case, the additional gate distant in one direction and gate home signal in both directions will be provided at a distance of block overlap. Gate home signal and distant signal of station is combined and called gate home cum distant signal of the station in the reception side. The advanced starter of station and gate distant signal are combined and called advanced starter cum gate distant at the dispatch side. The combination of gate home and distant signal of station will be a 4-aspect signal with a G marker. When normal braking distance is not available between home signal and gate, then the aspect control chart shall be modified accordingly. Level crossing gate in the vicinity of the distant signal. When distance between gate and station home is more than normal braking distance, then similar arrangement is adopted but do not require modification of aspect control chart. In this case, gate distance signal shall be with 2 aspects. Level crossing gate between home and advanced starter. In this case, home signal is shifted rearwards to cater block overlap distance, that is 180 meters from gate. Down home and up advanced starter shall be interlocked with gate. Level crossing gate between advanced starter and starter signal. Shifting of any signal is not required in case of single line yard, but in double line yard, the home signal shall be shifted to cater block overlap distance, that is 180 meters from the gate. Up and down home signal. Up advanced starter and up starters shall be interlocked with gate. Control of level crossing in automatic signaling sections. Interlocking. All the level crossing gates, irrespective of the class of the gate, shall be interlocked with stop signal. Warning bells. Warning bells shall be provided on all level crossing gates which will be activated by track circuit. Approach locking. All level crossing gates shall be approach locked. The maximum number of trains that can be dealt on a given section of railway during the period of 24 hours is called the section capacity. On single line, the section capacity is calculated as number of trains that can be run both up and down direction during this period. On double line sections, it is worked out separately. For calculating section capacity, some additional time is required. For closing of block section, for normalizing the signals and points behind the train and reporting to the station in rear, granting or receiving line clear for the next train, setting route and taking off signals, etc. This additional time is called the block operation time and is taken as 5 minutes. Running time of the train means time taken by the train to run between two block stations. Total time of 24 hours is divided by running time of any slowest train over this section plus block operation time. Scott's formula is the simplest for this purpose, which is as under for one direction. C is equal to 1440 multiplied by E divided by 2 capital T plus 2 small t, where C is section capacity, T equal to running time of slowest train, small t equal to block operation time, E is equal to efficiency factor, that is 80%. Calculating the section capacity on the basis of above formula, taking into consideration of the slowest train on the section, which would generally be a goods train. Former Great Indian Peninsular Railway refined this formula further and calculated the available capacity for running of goods train. In this formula, the total time consumed in running of passenger trains is deducted from the total time available to calculate how many trains that can be run in the remaining time. The formula is as under for one direction. CG equal to 1440 minus TP minus small t multiplied by K divided by 2 TG plus 2 small t. In this formula, efficiency factor K is taken as 50% gaps between passenger trains may not be usable for running of goods train. Steinbeck's formula, which is as under for one direction. C is equal to 1440 multiplied by small y divided by capital S, where capital S is equal to TA plus TB plus O plus W. TA is equal to running time on A side, TB running time on B side, O block operation time for two trains, W waiting time for next train, Y efficiency factor, that is 70%. All these formulas are however theoretical and do not take into consideration of physical features over the entire section. Indian Railways adopt charting method to give the maximum section capacity. It is the most practical way of assessing section capacity. Running of trains is plotted on time distance graph relating to the section. The time of all scheduled passenger trains are plotted on the graph, and in the gaps between different scheduled trains as many goods trains are inserted as possible. Section capacity mostly depends upon proper evaluation. detailed study of present and future traffic requirements. The optimum utilization of fixed assets like rolling stock, track, signals, etc. On single line sections, the line capacity can be increased by improving running time of slowest train and block operation time of Scott's formula. Efficiency factor, that is 80%. Running time of slowest train can be reduced by reducing the length of block section by providing additional crossing stations, increasing speed by providing mode of traction, tracks, rolling stocks and signaling. Block operation time may be reduced by introducing higher standard of interlocking, tokenless block instruments, panel interlocking, centralized traffic control and automatic signaling. Efficiency factor, that is 80%, can be improved by proper timetabling, punctuality, staff efficiency, upkeep of equipment's efficient operation, adequate number of loop lines, suitable length of block section by spacing of block post or stations and intermediate block signaling on double line, etc. Simplification of rules, training of staff is also the factors to improve the operating efficiency. The ultimate objective of increasing section capacity is to carry more traffic, not merely to increase number of trains, but to effect more reliable source of remuneration as well. Description: it is a siding in the block section on double line or single line. It is taken out from block section as it is not economical than to take out from block station. They are used to connect to ballast quarry, big industrial estate and when movement is very frequent. It is an interlocked point in the block section and protected as per standard 1 interlocking. Hence, generally a permanent speed restriction of 50 km per hour is imposed. Minimum equipment. The following signaling equipments at the siding are to be provided. A gauge tie plate where steel sleepers are not provided. A facing point lock or equivalent mechanism, the plunger of which shall lock each switch independently. Normally, point must be set and locked for running line. The mechanism is to secure the key taken out from locking arrangement of point from electric key transmitter or token exchanger. Speed indicator board shall be placed not less than 30 meters in rear of S marker. A caution and termination indicators. The point indication night aspect shall not lit on single line. Loco pilot enters into the block section under block protection with the key to unlock the point, stops near the siding, unblocks the point and performs the movement. Train is brought out of the siding, operates and locks the point in normal and returns to the controlling block station. Hands over the key to station master, after which block section can be normalized. During normal course of block working, train clears the point observing necessary speed restriction. The block section cannot be normalized until such time the key and train returns to the controlling block station. Siding on trailing points on double line. Siding point is provided on trailing direction to the direction of traffic on double line. Similar procedure can be adopted as on single line. The mechanism to ensure that the point is in normal position and locked is provided. As point is trailing, no speed restriction is required. Only S board, that is to indicate siding, is provided. Equipments for speed over 50 km per hour on single line. The equipments required at station using auxiliary key interlocked with block instrument. Equipments required at siding. Equipment at point as per standard 3 interlocking. A stop signal followed by permissive signal or passenger warning board. Working of trains. Normally the stop signal at siding is at off. When shunting is to be performed, loco pilot enters into block section under block protection with auxiliary key. inserts the key in the signal lever locked in reverse and normalizes the signal. Normalizes the lock bar to unlock the point. Point is reversed and movement is performed. The point is normalized and locked. The signal is reversed and key released and kept under the custody of guard, and train is brought back to the station, and key is handed over to the station master and block instrument is normalized. Control on siding point. Block instruments and token key exchanger. The equipment required at station and siding. Token key exchanger. At station without key and one token in the exchanger. At siding, key is in locked condition and without token in the exchanger. Electric key transmitter. At station, key is in locked condition. Siding without key in the electric key transmitter. Point equipments as per standard 3 interlocking. Working of trains. A line clear is obtained for the purpose of movement. The token is handed over to the loco pilot of the train. Train enters the block section, stops in rear of siding point. The token is inserted into exchanger to release the key for unlocking the point. Point is operated to reverse and train enters the siding. Point is set and locked in normal and released key is inserted into electric key transmitter to transfer to the station. Station master releases the key from electric key transmitter and enters it into exchanger to take out the token. Token is inserted into block instrument and block section is normalized. To return to station, loco pilot asks for the key on telephone and station master obtains line clear. Released token is to be inserted into exchanger to extract the key. The key is to be inserted into electric key transmitter and transmitted to siding. Loco pilot extracts the key at siding, unlocks point and sets it to reverse to perform movement. On completion of intended movement, loco pilot comes out and operates the point back to normal and extracts a key which is inserted into exchanger to obtain token. Loco pilot proceeds to either station as required and hands over token to station master to normalize block section. Based on the use of two auxiliary block instruments, the equipment required at station, block instrument at one station, additional auxiliary block instrument at other station, the equipment required at siding, auxiliary block instrument. Siding key is in locked condition and without token in the exchanger. Point equipments as per standard 3 interlocking. Working of trains. Line clear is obtained for the purpose of movement. Token is handed over to the loco pilot of the train. Train enters the block section, stops in rear of siding point. Token is inserted into exchanger to release the key for unlocking the point. Point is operated to reverse and train enters the siding. Point is set and locked in normal and released key is inserted into exchanger to release the token. Token is inserted into auxiliary block instrument and block section is normalized. Station master releases the key from electric key transmitter and inserts it into exchanger to take out the token. To return to station, loco pilot asks for line clear to obtain the token. A token is released and inserted into token exchanger to extract the key. Loco pilot extracts the key, unlocks point and operates it to reverse to perform movement. On completion of intended movement, loco pilot comes out and operates the point back to normal and extracts a key which is inserted into exchanger to obtain token. Loco pilot proceeds to either station as required and handed over token to station master to normalize block section. Description. Braking distance. The distance travelled by train after application of brakes and before train comes to a dead stop. It is important for determining the signal sighting distance. Application of brakes is of two kinds. A normal or service brake, which involves the shutting of the power and gradual application of brakes. An emergency brake, in which shutting off power and full application of brakes is done without any loss of time. Braking distance depends upon type of locomotive, type of rolling stock, wheels and wheel rail interaction, type of braking, that is air brake or vacuum brake, its integrity, load, speed and other factors, gradient, that is rising or falling, the state of rails, that is wet or dry, curvature of track and velocity of wind, season, that is dry leaves on rails lead to wheel slippage. Practical method of ascertaining the braking distance is to conduct trials at designated locations, prepare braking curves from data obtained from various test runs. Service braking distance: the distance required to stop the train running at the maximum permissible speed of the train permitted in this section at the rate of deceleration, so that the passengers do not get hurt or coaches and wagons do not derail due to change of momentum. Emergency braking distance: distance traveled by train before coming to a stop by sudden application of brakes at one stretch in case of an emergency. Emergency braking distance for a passenger train on level gradient at 100 km per hour is typically about 1200 meters. Generally, all multiple aspect color light signals are placed at a distance equal to emergency braking distance. Decoding of locomotives nomenclature. In this, the first item, that is gauge, is a single letter identifying the gauge of the loco runs on. W equal to broad gauge, Y equal to meter gauge, Z equal to narrow gauge, that is 2 feet 6 inches, N equal to narrow gauge, that is 2 feet. The second item, which is power, is one or two letters identifying the power source. D equal to diesel, C equal to direct current traction, A equal to alternate current traction, CA equal to dual power alternate current or direct current traction, B equal to battery electric, which is rare. The third item, which is load, is a single letter identifying the kind of load of the loco is normally used for. M equal to mixed traffic, P equal to passenger, G equal to goods, S equal to shunting, L equal to light duty, that is light passenger and no longer in use, U equal to multiple unit, that is electrical multiple unit or diesel electrical multiple unit, R equal to rail car. The fourth item, which is series, is a digit identifying the model of the loco. The fifth item, which is subtype, is an optional letter or number or two of them that indicates some smaller variation in the loco, like a different motor, etc. The last item, which is suffix, is an optional indication that indicates something special about the loco. Description and explanation. Railway signaling provides a vital and non-verbal communication between the ground-based devices, including track and the moving train. Therefore, it has to fulfill the following important requirements. All signaling components, equipments and circuits are designed to have the features such as fail-safe, reliability, simplicity and unambiguity. Fail-safe. Any equipment or system or subsystem or components in the signaling system under failure conditions must not lead to a signal showing off aspect or point moving or any other condition which may endanger directly or indirectly the safety of a moving train. In other words, under failure conditions, A stop signal shall display only red aspect, and a point mechanism must remain locked in the last operated position. This is known as fail-safe feature. Reliability. The equipments and circuit design must be dependable and follow the signaling rules with very high degree of precision. If reliability is poor, failure cause traffic disruptions and human intervention is necessitated to run trains under failure conditions. In case signaling equipment fails, safety is dependent entirely on human element, and if the staff responsible of train operations do not exercise proper vigil, there is a potential risk of an accident. Simplicity. The signaling system and its equipments are handled and operated by non-technical operating staff. Hence, the operation of these equipments must be easy and simple in nature. Unambiguity. The safe running of the trains is entirely dependent on the indication conveyed to the loco-pilot by the aspect of the signal. Hence, the aspect of the signal must convey precise and unambiguous information to loco-pilot. The aspect of the fixed signal shall be distinctive and unambiguous. The one aspect must have one name and one indication for all the types. The action required by the signal indication must be definite and easily implementable. Each and every signal shall afford minimum prescribed sighting distance. Number of fixed signals provided for the route shall be minimum. Block signaling to be independent of yard signaling. Failure in the power supply must not lead to any unsafe situation in any system of interlock.